Okay, so I'm Aaron Reedy from Data Classroom, and I have been working with PCC. And I just want to give you a little bit of my background so you know where I'm coming from. I'm an NSF postdoctoral fellow in biology at Auburn University, and I study natural selection in lizards. And this talk isn't going to be anything about that. But I founded Data Classroom in the middle of my PhD studies. And it really was because I had a prior career as a high school teacher in the Chicago Public Schools. In that time, I really struggled with stats with my students, and I loved doing labs and collecting data, but frequently the better data we collected, the more frustrating the experience was of analyzing and doing basic statistics. So I thought there had to be a better way, and so I built Data Classroom to be a statistical tool for working with data that's specifically designed for novices. I also want to say that Data Classroom will be available to all micro nanotechnology education center faculty and students through support through that NSF grant. So if you have questions afterwards and you'd like to start using Data Classroom or trying it out, get a hold of Jared Ashcraft or myself. But the problem that I was really trying to solve by building this web application is that the importance of data skills is just ever increasing. It's becoming the hottest job skill in the marketplace, and it's just permeating fields far beyond the traditional STEM fields, which have sort of always been data rich. Few data tools out there are designed for a true stats novice. Many instructors get by with Excel or Sheets. Stats in the command line like R or Python are a good alternative, but they do demand some dedicated time to operating in that environment. And I wanted to make something that could sort of speed you past that time and get you right to graphing and statistics. So the solution that I have been building is Data Classroom, and it does a few things. One is that it creates beautiful graphs in seconds, like these that you see here, but it can create many different types of graphs. It's extremely flexible in that way. It explains the math behind hypothesis testing through animation, so that students are not just operating some kind of black box equation and getting out a p-value at the end, but they actually can go through these calculations step by step, see the quantities that drive the numbers and how they're connected to the raw data points. And then also once students get the basic handle on applying statistics, it supports the appropriate choice of statistical tests for normal data. For this, at this point in time, it's only a fit for working with normally distributed data, but we hope to someday in the very near future have sort of the non-parametric equivalents for many of the hypothesis tests in there. So I just also want to say that without giving, sort of a full demo on this, Data Classroom was designed with pedagogy in mind at every step of the way. So it's not just meant to be a tool to do statistics, but it's a tool meant to learn as you do. And so a couple of things I want to point out is that all of our default plots show raw data. We do not have bar graphs as a default plot. We want students to understand the role of variation in interpreting a result. You have the ability to layer multiple representations of descriptive stats on the same plot. So like what you see in this example, showing you the median and the mean on the same plot with two different visuals that are dropped right on top of the raw points. And the whole idea is that we are attempting to reduce the cognitive load of creating graphs, getting students to spend less time with buttonology or sort of troubleshooting simple code, and allowing students and instructors to spend more time on higher order interpretation. And then finally, I just want to point out that the whole app is built around the principles of tidy data. So unlike Excel or Sheets, if your students are working in Data Classroom and then they move up to the command line environment, all the concepts of a variable are going to be conveyed in much the same way. And so they will be well prepared to work in an environment like R or Python or something else. So with that, I will keep under my 5 minutes and end right on time.